Okay, we're going to start Unit 1, Lesson 7 with a little which one doesn't belong. And here we have these 4 polygons, A, B, C, and D. And what we want to do is we want to determine which one of these does not belong. So there's no real right or wrong answer to this, but what you may notice is that for polygon A, this one might not belong because it's the only one that is shaded. For polygon B, some students say this one doesn't belong because it's the only one that doesn't have equal sides. So sides not congruent, right? Congruent sides have equal length, and these are not equal length. For polygon C, some people say this one doesn't belong for 2 reasons. One is no right angles, or the angles are all different. And other people say only one that doesn't sum to 8. So the perimeter is not 8. Okay, and then for D, some people say this one doesn't belong because it's the only one that is not a quadrilateral. Whoop. Okay, that's the only one that's not a quadrilateral. So a little bit of just a warm up here to get us looking at shapes and trying to talk about them. So if we scroll on down, we're going to start with It's Cool to Be a Square, 7.2, and we're going to use a straight edge and compass tools to construct a square so that AB is one of the sides. And to do that, we're going to go to the lesson, the applet, construction applet that's built into the lesson, and we want to make sure that AB is one of the sides. So the first thing we need to think about is what makes a square a square? Well, a square is a quadrilateral. All 4 sides are equal length, and all 4 sides, I should say, all the angles are 90 degrees. So the side lengths have to be perpendicular to one another. So that kind of gives away what we're trying to do here. We need to make sure that when we take the sides of our square, they have to be perpendicular at A and perpendicular at B. So to do that, we're going to start, I'm going to scroll a little bit here to make this a little bit smaller. And the first thing I'm going to do is I am going to extend segment AB to make it a line. Perfect. Now, I simply want to draw a line perpendicular to AB that intersects at one of the vertices. So to do that, remember, what we want to do is we want to make sure that we have a segment here that we can draw the perpendicular bisector of. So now I've drawn this circle with centered at A with radius AB, and I know that segment CA is the same length as segment BA, so A is the midpoint. So if I can draw a perpendicular bisector now of CB, this diameter, then I know I've cut, then I know that my angle here will be 90 degrees. So in order to do that, remember, all we need to do is draw a circle centered at C with radius CB, draw a circle centered at B with the same radius, and connect these intersection points. Points D and E. So now I'm going to draw a line connecting D and E. Perfect. And I have a perfect 90-degree angle here because of that perpendicular bisector. Now, since my square has to have equal side lengths, I know that the intersection of this circle centered at A and this perpendicular bisector, this must be another vertex of my square. So, in order to draw my next side, what I'm going to do is I'm going to find a line that is perpendicular to line AB, but now it's going to intersect at B. So I'm going to do the same thing, but the first thing I'm going to do is I want to hide some of these circles so that I don't get them confused. And I am going to draw a circle over here so that B is the center. Right, so I'm going to draw a circle so that B is the center. Perfect. I'm going to put another point over here. Now if I draw the perpendicular bisector of GA, then I know that I will have a 90-degree angle at B. So to do that, I'm going to draw a circle centered at A with radius AG, a circle centered at G with radius AG. Same thing, find these intersections and connect them with a line. Now, if I find this intersection point, I know that my circle centered at B with radius BA, this radius must be the same, B to J. So I found my fourth vertex. Now I can use the polygon tool and I can just draw my square. So there it is, a circle, a square drawn so that one of the side lengths is AB. Now we're going to come down here to 7.3. And in 7.3, what we want to do is just kind of follow the instructions here. So we want to construct a circle centered at A with radius AD. Centered at A with radius AD. Then I want to draw a circle, construct a circle centered at C with CD radius. Perfect. Now I want to draw the diagonal of AC. So from A to C. Okay. And I want to write a conjecture about the relationship between BD and AC. So my conjecture is that it appears as though BD and AC cut each other in half. And when they cut each other in half, we say that they bisect each other. So it appears to me as though AC and BD bisect each other. It also looks like they are perpendicular to one another. Okay, so we can say that AC and BD appear to be perpendicular bisectors of one another. Now, moving on to part D, we want to label the intersection of the diagonals as point E. Point E. Construct a circle centered at E with radius EB. Centered at E with radius EB. And notice I've drawn a circle that circumscribes this square. Circumscribes mean that the circle goes around and every point that is a vertex of the square is on the circle. How are the diagonals related to this circle? Well, it looks like the diagonals are the diagonals to this diagonals of this square look like they are the diameters of the circle. So now we can come down here and use my conjecture, straight edge and compass to construct a square inscribed in a circle. Well, we said that the diagonals were the diameters of the circle, and they were perpendicular bisectors of one another. So if I draw a if I draw a line that goes through the center of my circle, what I can do is I can create this diameter. Now, if that's our diameter, and we think that the diameters are perpendicular bisectors of one another, so all we have to do is find the perpendicular bisector of CD. And in order to do that, I draw first a circle centered at C with radius CD, a circle centered at D with radius DC, so these two big circles are congruent. Now, if I draw a segment connecting where these circles intersect each other, what I can do here is I found the other vertices of my square. So now I can just draw a polygon, use the polygon tool, and I can construct the square. All because it looks like the diagonals are perpendicular bisectors of one another. So we're just going to create these, copy and paste them into your notebook, and we will be good to go. If we come down here and look at the summary, something that's important here is a square is an example of a regular polygon. Regular polygons, all the sides are congruent and all the angles are congruent. That's what makes a polygon a regular polygon. All right. Thanks a bunch.